Okay, we have your image also now. So, okay, I would like to introduce as our first speaker, Professor Olabi. He is professor at University of Sharjah. Professor previously was at the University of West of Scotland, I think. Now, his title is Digital Twin and Artificial Intelligence for Renewable Energy and Energy Storage Systems. So, Professor Olavi, you have 40 minutes to talk, and last 5 minutes should be reserved for questions. Please start with your presentation.
Hello, good morning, everyone. Can you see my screen and my presentation?
Yes.
Yes,
Yes,
okay.
we can see. Yes, yes.
Okay, thank you very much. Thank you for your invitation, and I am sorry I didn't manage to come in person to your conference and to your university. So I wish you all the best, and I'm sure it was a fantastic conference for the last 2 days. So what I am going to talk today about digital twin and artificial intelligence for renewable energy and energy storage systems. This is a new technique. Normally, we use like renewable energy, we use energy storage system, we look at X energy, and so on, and a lot of things related to energy storage, starting from hydrogen, blue and green hydrogen, and so on. But with the new tool we have, like the digital twin and artificial intelligence, this will help us to do the work faster because we have the right tool to do it. So this is what I am going to talk today about it. Before like I start, only like to tell you, to introduce myself, I am directing the Sustainable Energy and Power System Research Center. So the research center, we have 5 groups. One group working on renewable energy and energy efficiency, one group working on biomass and bioenergy, another group working on nuclear energy, here energy storage, which I am working on it, energy storage system and storage management, and then we have smart grid. So the center very active. They have annually around 500 publication. We have around 15% on the top 2%, and we have a lot of patent and research impact. So to start with, why we need to go for artificial intelligence and digital twin, I like to mention about some development we did on fuel cell. So this is later on to connected and correlated with the digital twin. So we a few years ago, we got patent because we changed the flow plate of the hydrogen fuel cell. So this is only an example. This is a fuel cell, and this is like we did number of prototype, and you can see the size of the fuel cell can go for mobile phone, but also it can be scaled up to do it like for any other application. Another thing I like to mention, which we are very interested to work on energy storage, is compressed air energy storage. We are doing good progress. Of course, the density of this storage is, we cannot compare it to batteries, but it has a lot of advantage. I'm not going to talk about the advantage, but this is one of the important project we feel we are going to progress and to have hopefully a very good development and innovative system. Also, like recently, and everyone, like maybe all governments, they put in their strategy hydrogen, and it can be green and blue, and of course a lot of other type of hydrogen, but it show like hydrogen is very important. So for us in the research center, we consider like we have to look at the developing the material of, the production of, will help us in the production of hydrogen, green hydrogen. We need to look at non-conventional water because, as you know, when we use electrolyzer, we use normal water, fresh water. So we need to go to look at wastewater, how to use wastewater and saline water. So there is a lot of development on this area, a lot of things on electrochemical storage devices, a lot of development also on mechanical and thermal storage devices. We believe energy storage, it's really very important topic, and starting from hydrogen going to all other topic, it's really important because how we can store the energy. Here I don't want to stop. This is only to show a few buttons on some electrochemical development. For some material we use it either in supercapacitor, fuel cell, or batteries, and so on. When I start, before starting using digital twin and artificial intelligence for renewable energy, I want to see why renewable energy. So renewable energy is very important because as you can see, this is traditional figure. I think everyone maybe saw this figure. So the figure shows us like how the emission is increased, the CO2 emission increased after 1950 up to now, increased by tens and hundreds of times. So here, like, the emission was very low, and this is no one were talking about climate change at this point because emission was okay, reasonable. But later on, with the increment in industry, increase of transportation use, increase of the number of car and vehicle and so on, increase of the flight number and so on. So the aviation sector also, it has produced a reasonable number of emission and so on. So you can see the number of emission is increased. So now it is not really choice to have renewable energy. Before, okay, we need renewable energy because traditional energy maybe sometime it will disappear, will finish. But actually the renewable energy is more really than only we need energy. We need really clean energy. Otherwise, the emission will be so much, and the climate change will be suffer from the emission. As you know, like, storage is important, and this is why I'm going to talk about storage system in using digital twin and artificial intelligence. So as you know, here we have, this is the renewable energy, so we need to store the extra amount. So this is what we need, and so we need to store to use it on the time where we don't have renewable energy. I don't want to go, this is only traditional also figure to talk about what is the energy storage in general, because again, from my talking today, we will talk about renewable energy and energy storage system. So renewable energy, well done, well known about, from solar to wind to biomass to hydro and so on, and geothermal, of course, until like we need to store, so we can store either electrochemical or mechanical or thermal or chemical storage and so on. So this is like where we come now to talk about digital twin. So I will start my talk about digital twin. When we talk about digital twin, we need always to think about what is about Industry 4. So now you will see, I will show you the connection between digital twin and Industry 4. As you know, Industry 4 started after like Industrial Revolution. So here we start with Industry 1, when machine production with the help of the steam and water. So here when we started the initial, like there has machine and working with the steam and power and so water, and this is the initial one. And then this is in the 17th century. In the 18th century, we have the machine powered by electricity and combustion engine. And this is maybe the beginning of the Industrial Revolution. Here started something, but here really where we have like particular, I can say electricity important, but I think more it's a combustion engine. This is a real revolution for in general for industry. In the 20th century, we have the introduction of using computer, IT, industrial robotics, which result in advanced automation and manufacturing process. So here's a progress was clear. And when we go to Industry 4, we talk about the introduction of Internet of Thinking, advanced computer system, artificial intelligence, cyber physical system, and digitalization. Here what we talk about digital twin. So actually like AI and DT, artificial intelligence and digital twin, they came really at the Industry 4. And this is why we talk about, I like to give some few minutes to talk about Industry 4, because this is the direct connection Industry 4 with artificial intelligence and digital twin. So Industry 4 like was announced in 2011, and now, as you know, maybe we are going toward Industry 5, where there is more progress, particular on the AI, DT, and robotic, and so on. So here, like, it's network of manufacturing resources. So here we have the manufacturing resources can be machinery, robots, conveyor, and so on, that are autonomous, capable of controlling themselves. So this is like controlling themselves. It means there is a robotic, there is a program, there is an algorithm behind which make all these things. So here, like, so here self-configuring, knowledge base, sensor equipped, and so on. So here, like, you can see also the classification and when it's started and where we are now about Industry 1, 2, 3, and 4. Here, when we talk about today, what we have, Industry 4 is revolution and evolution, or we need to know, is the Industry 4 a revolution or an evolution? So we will see. So I think it is both. We have technological evolution and we have business revolution, because the business improved a lot, like increased hundred of times because of the technology. And this is a technological evolution because we are getting all these tools. So what is the principle of I4? I4, it's modularity, so the ability for system component to easily separated and recombined according to specific application. Decentralization, so this is the ability of different component of system to work and make decision independently. And virtualization is the ability to replicate system in virtual and allow real-time monitoring. So we'll talk a lot about virtualization. Real-time capability is the ability for system to respond instantly to a request, and we have interoperability, the ability for system to or product to cooperate and exchange information or service with other systems. So here, like the connecting with two systems or product, a complete and reliable manner and with resource optimization. Then we have service orientation, so manufacturing as a service and product as service. So this is like a new concept. So now from this IT4, I want to see like what is the main element of Industry 4. So the main element is IoT, Internet of Thinking, enable physical object to communicate with each other. So because we have this Internet of Thinking, further to share information and coordinate decision. iOS is concerned with systematic use of internet for new ways of creation through materialization of product as service business model. Big data, so everyone know, like, here about big data. So we need big data, so it means analysis, so we need to have artificial intelligence. So, and here you can see this two item, artificial intelligence simulation modeling. This is really the core what we want to talk about, artificial intelligence and digital twin. So here AI will enable organization to better gain value from the massive amount of information they already have and identify what is likely to happen next and what action should be taken to achieve the optimal result. We have a cloud of computing. I will not go a lot. We have augment of virtual reality. We have additive of manufacturing or additive manufacturing. Here's the second point I want to talk about. This is simulation and modeling technique. So simulation and modeling technique, here we come to digital twin. So design, realization, test, and running of virtual system to simulate and emulate the behavior of physical systems. So here when we make virtual system and we compare or correlate it with the physical system. So then we have automation and industrial robotic, and we have cyber security and technology and so on. So a lot of all the topic is important, and this is what they make the revolution of Industry 4. The main component, like what we want to talk, and really they are the basic of Industry 4, they are the AI, artificial intelligence, and the virtualization, which where we come to simulation modeling technique, where we are talking about digital twin. So here only like this is Industry 4. So here Industry 4, in the past, we have only physical space. So this is a physical space. So what we mean by physical, everything we do physical, like, so we compare, we make experiment to compare, we make experiment to improve, and whatever result we go to improve what our physical system. Recently, we have the interaction, we have physical and we have virtual, and here we get the cyber, what we call it the cyber system, and there is kind of interact between the two systems. Here, when we come to now, current, and the future, here where we come to the cyber physical system, where we call it the digital twin. So here they are connecting, not only correlated like before, here they are working together. So I have the physical system and I have the virtual system, which is exactly the same like the physical. Whatever I do in the virtual system, it will go to modify the physical system. And whatever I will get in the physical system, it will go to be reflected on the virtual system. So this is really what we call the digital twin. So here I don't have only connection comparing. I have two physical and cyber system, and whatever I modify, I optimize in the cyber system, which is the virtual system, it will go directly to modify and optimize and give whatever information we need to the physical system. So here's the history of digital twin. So digital twin initially started in 1970, of course, by NASA in their work. And then 1991, so there was like some period why we stopped a little bit, because as you know, when we talk about simulation and optimization, we need very high computer capacity. And here where we got in the 90s, really started to get better devices. So here, David Schlementer discussed software modeling to replicate the real operation and physical system here. Then in 2002, another professor started to get the early concept of digital twin. In 2006, there was more about, we call it information mirroring model. So like how to duplicate, like mirror you have. And then in 2010, NASA declared first team digital twin. So here officially they are talking about digital twin. Before like was concept, it was initial work. Here it was officially like declaring we have digital twin. Now currently digital twin is integrated for health, maritime and renewable energy, and a lot of application, because it's very important. More information, you can find it in different paper we did and other colleagues did. So now we want to tell what is digital twin. So digital twin simply is an adaptive model that emulate the behavior of physical system, getting real-time data to update itself along its life cycle. So here, like we have the physical system, it have all the real data and it go to update itself. How? Because the digital twin replicate a physical system in the cyber system. So we have the physical system and we build the virtual system to predict failure. So the virtual system, because we have the algorithm, like we have the software, we have the machine learning inside. So to predict failure and opportunity for changing in order to prescribe real-time action. So it will give us action to the physical model directly for optimizing and or mitigating unexpected event, observing and evaluating the operating system profile. So I have the physical system. I built similar, exactly the same system, but it was virtual. I have all the information of the calculation. It is in the virtual system. it will give me feedback to the actual system. So if I have, for example, we will see some example. I don't want to anticipate. So we have some example to talk about it. So here, starting, for example, digital twin, and we told the 4 questions leading to digital twin. The four question, it's when I start, I want to know where I can use this digital twin. So I can use it here in a lot of things, like I can use it manufacturing, in environment, in aviation, or renewable energy, in oil and gas, and so on. And the second question, when? So when I need to look at this life cycle, I need to look at the production bill of material and so on and so on. So it will help me a lot. And the third question, why? Why? Because I want to predict if I have any fault, so I can predict the fault. I can make remote monitoring. I can improve the product design. I know what is the customer need, and so on and so on. And then the last question is how. So how, it's really like by duplicating the virtual, the physical system, by the building also the virtual one, the cyber system, and let them work together. So any feedback from the virtual system, it will go directly to the physical system. So I can look at it, sort a lot of issues. So what is the advantage? Why we want like digital twin? So digital twin has a lot of advantage. Like it can have simulation and optimization. So when I simulate the cyber or the virtual part, so it helped me to get like optimize, make the best condition, predictive maintenance quality, because of course, when I have the virtual, I can understand when I need to make any maintenance for my batteries, for my wind turbine, for solar panel, and so on. Improve product design, because I'm looking at the virtual. So if there is any issue, I might improve it, change the design, and it will be, I can go to check if I can change also something in the physical, and so it will lead for further improvement or continuous improvement. Remote monitoring, so I'm monitoring the system always, and real-time analytics. So here, like whatever I'm getting from the virtual, so it's on real time, I am getting information and I can feed it to the physical system and so on. So here, like this is, for example, digital twin. I have physical twin, so physical system, I have sensor, actuator, controller. So this is, I need sensor, actuator, controller, because this is will give the data and measurement, events, and action. It will go to the virtual. So here's the digital twin, digital model, algorithm, analysis result. So here I have analysis result, and because I have here what is the component, I have machine learning algorithm. We will get all this information and analyze and so on, and physical behavior and simulation model. So here I have the simulation model. It go again to the machine learning, and later on the outcome here, it can go to the physical model. So here, for example, I have control parameter, recommendation, action, estimation, fault detection, and diagnosis. So all this information we can get it. So from the physical, we go to the digital, and again, here's the information from all sensor, actuator, controllers, and so it go to machine learning and physical behavior simulation model, and then I get the feedback and I feed it to the physical, where I can make the change required, and then it will be here again. So the new change, it will go directly, so it will update the virtual model, and again, we keep repeating and doing the same. So here, why digital twin? I mentioned earlier, so digital model, so the virtual model is developed based on the physical model. Machine learning algorithm, various machine learning algorithm are integrated to perform specific function. Prediction, so this is important. So machine learning algorithm provide various estimation and prediction from the real-time monitoring data from the digital model. Improvement, so here later on when we get the information, we go to the physical model. So the improvements, the prediction and estimate circulate back to allow physical system to adapt to the upcoming alteration. So here, like, I give the information and I develop my model. Here only like to show you physical model also developed by one of our colleagues. So here, like, it's not related to energy, but only to show you it was more on the manufacturing process. So this is like machine, and here's a virtual machine, and there it's connected. So this is the virtual, and so everything we modified or optimized by the virtual model, it will go to be adopted by the physical model. So we need to adopt all the information, all the support we get from the virtual to the real model, to the physical model. So digital twin application for renewable energy and energy storage systems, there are a lot. So we can apply it, as I mentioned, in wind energy. We will see some example, solar energy, biomass, hydroelectric energy, geothermal, pump hydro. For the energy storage size, we can look at battery, thermal energy, flywheel, buoyancy, hydrogen production, compressed air, and so on. We have, like, we look at in the literature, there is a lot of work done using digital twin. So we can see the maximum, it's on wind energy, so, and followed by solar energy, hydro energy, geothermal energy, and biomass. So it means it show really good increment in using digital twin in the last few years. So, and I think from what we see in the literature, and so there is more improvement or more use for this tool, like to apply digital twin in renewable energy and energy storage system. So here we will look at example. For example, digital twin for application in thermal energy storage. So here, like in thermal energy storage, we have like the system. We define, implement the digital model. So in digital model, we have simulation, we have domain technology, we look at the time, we look at the mathematical model, we have knowledge driven, and so on. And then we look at the digital data, we call it DD. We have the Internet of Thinking, shared knowledge base, and so on. And here we have the simulation service. And between, we have interface, which we have protocol, industrial communication, industrial Internet of Thinking protocol. So this is the software which will help us to, and here, like, so from the physical model, we have like the sensor, we have thermocables, we have the information we need to feed to the virtual model. And here we build the modeling. So here we have the model exactly similar to the physical model. Exactly. So here when we get the information, we make the evaluation, and then it will give feedback to the system and to the physical model, and the physical model again will work side by side with the cyber model or the virtual model. Whatever feed I give to the virtual, from the virtual to physical, so physical will be changed to adopt whatever support information you received, and again the virtual model will be updated again according to the physical model, and so on. Here, like digital twin application for battery, also we work on this one. So here we have battery, we have similar thing. I don't want to repeat. We have, like, here we have the model, we have the sensor actuator, we have the digital model, we have the interface, and again we have the evaluation, and we have this circle. Whatever information we give to the physical model, again we will get feedback, and it will go to the virtual model. Any update on the physical model, it will go to update the virtual model, and the virtual model will keep working on optimizing the system, getting the required information and feed it to the physical system. Another work we are looking at, and we did, it's looking at fuel cell. So fuel cell here, we have the fuel cell. This is the physical fuel cell. We have the digital one, and between we have the connection layer. We have the estimation of lifetime, monitor of the battery, state of health, and so on. Here we give the information data to the cyber model, and at the end also we get feedback, and this feedback will go to the fuel cell, to the physical model, and we repeat the same cycle I mentioned earlier. We have digital twin application for in general energy, for hydro energy storage system. Again, similar, we have the physical model, we have the data, we give the virtual model, and again, so here we have the digital twin, and then will give us information about, for example, service, fault intelligent diagnosis, and so on. So information we need maybe to look at the service of the hydro system, or any information needs, so it will change, will be implemented to the physical system, and again we will get this information back to the digital space. We can apply it also for wind. It's very, like you saw earlier, so a lot of research working on this one, because you know, wind turbine, it's first high and all the component on the top, and so if I make virtual model, so I can get directly the feedback without affecting the work of the wind turbine. So the same, I have physical model, I have connection with by sensor, I have also SCADA, I have actuator, and so on. I feed my information to the digital layer. I give information, for example, service optimization, monitoring test, and so on, and I give it to the physical model, and it will be updated, and again, the new feedback will go again, and it will continue the same way. This is what I want to say very fast about digital twin. Of course, like you notice, there is a lot of thing we did simulation and a lot of references you can look, and if you are interested, you can ask. I will talk a little bit about artificial intelligence. So artificial intelligence technique, I think everyone now know about artificial intelligence, starting from what we talk about to a lot of things going on the teaching and learning and so on. So artificial intelligence become very important industrial software, very important knowledge, very important thing we needed in our life. And big negotiation was between America and China about artificial intelligence. So artificial intelligence in general, very well known, is technique which enable machine to mimic a human behavior. So machine, it will optimize, it will tell us a lot of things, and it will reduce the work of the human. And this is what we notice even in teaching and learning software. Machine learning, subset of AI technique, which use statistical method to enable machine to improve with experience. So here machine learning, it helps, like it's supplies the artificial intelligence with the information. Before the machine learning, we have deep learning. It's subset of machine learning, which makes the computation of multi-layer neural network visible. So here I start with the initial regulation. I have the step higher, which is the machine learning, which will go all to artificial intelligence, which will do the final optimization. Let us put it in this one. So here, what is artificial intelligence, function and benefit? So here, as artificial intelligence, I have machine learning. So machine learning, it will help us for energy, for example, working about energy forecasting, predictive maintenance, load management, fault detection, capacity planning, battery health monitoring. And we go to robotic, we have solar panel cleaning, inspection and maintenance, battery manufacturing, testing and recycling, quality control for quick detection, visual inspection for monitoring. We have here about natural language processing, energy consumption, regularity, and safety consumption. And all this come under the artificial intelligence benefit in the sector. So it has a lot of things where I can look at energy forecasting, I can look at planning, I look at testing, recycling. So all this issue related to energy, I can look at it under the umbrella of artificial intelligence, which will help me a lot, will make the work faster and precise prediction.
Professor Olabi,
Yeah,
please try to
yeah, I am
conclude.
about finishing my presentation. Thank you. AI can improve the process and make it more efficient, such as energy sector, making electric grid, optimize demand, manage energy, identify new materials, improve computing, help in optimizing, and so on. So a lot of benefit. This is also the way how we look at the methodology. You can look at it about artificial intelligence. Here, how it works, like there is different example. You can look at the references I have here in this presentation, how artificial intelligence work, for example, on hydrogen production, work on compressed air energy storage. It can work very well on, in general, about energy storage system and so on. So thank you very much. This is also thanks to my team who work with us, like my collaborator, my colleagues, and so on. And thank you very much. And if you have any question, please go ahead.
Thank you, Professor Olabi, for a very interesting talk, and also thanks for keeping the time. Okay, now we will try to ask questions. I will take the questions from the audience and then tell the questions to you. Are there any questions? Any questions? No. So the presentation.
Okay, it's too early for a question, I think.
So, okay, then when there are no questions, let's thank to Professor Olabi for his presentation. Thank you very much.
Thank you very much, and wish you all the best in the conference.